Okay, welcome to Foundations and Pre-Calculus Math 10 with Mr. Johns. We are just going to start section 5.4. We'll start with the skill builder. And we're going to start graphing on a coordinate grid, or plane is the other word we often say. And so an ordered pair tells you the position of a point on a coordinate grid. We often think of it as x, comma, y. And so the first number tells you the distance left or right from the origin. So this would be 2 to the right. And the second number tells you the distance up or down from the origin. So this would be 3 down. So to plot point A, 10, 15, we would start at 10 on the horizontal axis here, and then go up to 15 there. Point B, which is 0, negative 5, we would go 0 left and right, and negative 5 would be 5 down, so this is B. For point C, negative 10, 0, we would go to negative 10 left and right, and then 0 up or down. So this is point C. On this grid, the first square represents 5 units. We chose this scale because all the numbers are divisible by 5 in the ordered pairs they gave us. So we often think of this as the x-axis, and this is the y-axis, and that's why the first number is x, the second number is y. Now, write the coordinates of each point on the grid. So point D, if I look, this is negative 4, positive 4, so each square is 2 units. So left and right, I'm going to go 2 units left, which is negative, and then 4 units down, which is also negative. For point E, I will go 0 units left and right, and 2 units up. For point F, I will go 2, 4, 6 units to the right, which is positive, and then 0 units up and down. For point G, 4 units right and 4 units down, so positive 4 and negative 4. This one says to plot and label these points on the coordinate grid below. I'll let you try this one by pausing the video. Watch me if you need help. Now the next part of this lesson is section 5.4, and this is a math lab about graphing data. And this is quite a fun little lesson because we get to graph data and investigate the domain and range when the data represents a function. So this is an experiment you get to do on your own. I don't mind if you work together, but you should each do it. So you'll each start with a piece of string. Okay? And you need a ruler. And that's about it. So record all the measurements in the table below. Measure the length of the rope without any knots. So here's my rope, and I need to measure that without any knots and make sure it's nice and taut. So starting at 0, I'm going to use centimeters in this case. And measuring it, I get 20 centimeters. So with 0 knots in my rope, I have a length of 20 centimeters. Tie 1 knot in the rope and measure the length of the rope with 1 knot. So what I want to do is tie 1 little knot in my rope. And I want to be consistent about making my knots the same size and tightness. And now I'm going to measure the rope again. Be careful with the frayed ends. And I'm getting 18 centimeters. So with 1 knot, I get 18. And now I need to, once I keep making knots and keep measuring my distances, I'm going to pick a scale for my vertical axis so I can use all my measurements. Now remember, you might not have started with a 20 centimeter length of string. Yours might have been different. So your graph might be different. Label your vertical axis. Pick how many centimeters for each square. When you're graphing the data for your length of rope, this little squiggly line means you can skip some space. So you're able to, you could start at a number greater than 0. So if my rope only goes as short as maybe 14 centimeters, I can start at 13 or 12 and go up by 2s or 1s. So keep that in mind when you're making your graph. And then label all these points on your graph. After that, you can answer the questions about joining points, part C for the domain and range, and here. Once you've done that activity, we can move on to practice. But I'm going to do a few of these with you and talk about them so you can make sure to know what you're doing. So once you've done the lab, number 1 asks, would you join the points on a graph below that represents each relation below? Circle your choice. So the question is, if we have a graph and we have dots, sometimes we would connect the dots with a line, but sometimes it makes more sense to just leave it as dots. And we'll see here. The relationship between mass and age of a baby. Now my answer in this case is, should I connect the dots or should I leave them as just dots? And I'm going to say that yes, I should connect them, because every little day or minute or year the baby gets older, there'll be a bunch of different masses. They can all be connected. It'll keep growing and growing. Now if I look at the relationship between the number of ice cream cones sold and the outside temperature, I am not going to connect the dots because I'm not going to sell 1.5 ice cream cones. It'll just be specific numbers, and so I'll just leave it as dots. Go ahead and finish all of number 1. Number 2 says, this table shows the number of cars in a school parking lot during the day. And so I have this table that talks about time and the number of cars. Then what you need to do is, just like with your string, graph that. I'll let you do finish number 1, do all of number 2, then answer the questions about number 2. You do not have to do number 3. And that's it for today. Good luck. Let me know if you need help. We'll continue on tomorrow.